Hello everyone, welcome to the next session of Alam Bradley PLC. So in last session we have already discussed about the central processing unit as well as the power supply required to the PLCs. In this session we are going to discuss about the input module of the PLC, output module, rack and the bus system as well. So let us start with the input module. So input module means what? In the PLC, there are two different input module which you can observe. The first one is the digital input module and the second one is the analog input module. So digital input means what? Digital means what we can say it consists of two states. The first one is the on state and the second one we can see the off state, right? Or similarly we can see it 1 or 0 state also in the binary state, right? Or simply we can see the discontinuous process. Okay, so in the digital input we can observe the switches, push button, relay, proximity switch and the float as well. Okay, the proximity we can see it, the sensor also in order to detect the object. The float means what? If you are designing the program for the water level management, in that case, what we require some other float sensors, right? So as per the requirement, we need to select digital input devices. So here I have mentioned the required power supply, the 24 DC power supply, then 110 volt AC, 230 volt AC, right? Along with that, here you can observe the analog input module also. So analog input means what? The continuous signal which varies with respect to time. So here I have mentioned some example which are related to the analog input mode. The pressure, flow, level, transmitters, then a thermocouple, RTDs also. RTD means what? The resistance temperature detector. Means, for example, if you are working in any chemical plant and if you want to know the temperature of that chemical tank, so this is possible only by using the RTD. The RTD means is nothing but the analog sensor, right? So here I have mentioned the required power supply for this analog input, 4 to 20 milliampere and 0 to 10 volt. Basically, 4 to 20 milliampere is the analog input for the unipolar devices, or if you want to read only positive reading, in that case your the analog current range selection should be this 4 to 20 milliampere. If you want to know the negative as well as the positive reading, okay, means like this, in that case you have to go with this range, minus 20 milliampere to plus 20 milliampere. So this is the reading for the reading in case of the bipolar case, means if you want to know the positive as well as the negative reading. Similarly, in case of the 0 to 10 volt also, this is the analog voltage range. If you just want to know the positive value, okay, which is coming from the field. For example, if you just want to know the temperature range in between 0 to 100 degrees Celsius, you can go with this range 0 to 10 volt. But if you want to know the negative reading, like minus 50 volt to minus 50 degree to 100 degree centigrade, so in that case your voltage, means the analog voltage range selection should be this, minus 10 volt to plus 10 volt. Always remember, means as per our requirement we have to change the range of analog current as well as analog voltage also. Basically, the input module, what we can say it is the link between field input device or sensor and the CPU, right? So basically, in the previous session, we have already discussed about these things. Like here, you can observe the PLC signal flow. So this is our input module, right? Means basically this input module links to the CPU, means like this. Here you can see the switch and the CPU connection is getting. And the most important part that which you should know about the input module, that is nothing but this transfer of data. This transfer of data that take place between the input sensor to the CPU only. Means when I press the switch, right? press the switch, it will send the signal to the CPU. Right? And we have already discussed what is the role of CPU. It will update, it will the process that downloaded program, execute the program, and accordingly we will get the output. And the most important thing, that is nothing but the converter. Right? If you don't have the provision of DC power supply, right, and as we know that our requirement is of 24 volt DC power supply, so simply we can go with the SMPS. This SMPS will fulfill the requirement of our DC power supply. Right? Here you can see. So if you have provided 24 volt DC power supply to the PLC, then it will convert it into the 5 volt DC. So as we know that the required power supply to our CPU, that will be 5 volt DC. So that is the reason the conversion takes place. And if here you can see you can directly provide the 230 volt AC power supply also, but in between them at least there will be the connection of and the presence of SMPS. Then and then you can able to accomplish the desired power supply. Now the most important thing here, you can observe the isolation part. So we can able to provide the isolation by using the optocoupler. So what exactly the optocoupler? Optocoupler means what? It provides the isolation between power circuit and control circuit. Right? I'm just going to tell you a few more things about the optocoupler. Basically, the optocoupler consists of the transistor and photo transistor and the photodiode. Okay, so just for your understanding, I'm just showing you, I'm just drawing one circuit diagram so that you will get more idea about these things. For example, here this is the resistor and this one is the diode. Right? Basically, in this optocoupler concept, the diode acts as a LED. Okay? So this one is the diode, and here is the transistor. Okay. So as you all are aware about the transistor is having 3 different terminals, right? Okay. I'm just highlighting the terminals. This one is the collector, this one is the gate, and this one is the emitter, right? Okay. So as you are providing the power supply, this diode act as the LED, means the light will incident on the gate terminal. It is possible only when the diode acts as a LED, right? When the light incident on the gate terminal, here it is, right? The gate terminal heads up, right? So when the gate terminal heads up, then accordingly you can observe some other changes. Okay, changes in terms here I'm just telling you. Okay, the one more thing. To the collector terminal, you can observe the power supply. The VCC will be there. VCC will be of plus minus 5 volt, plus minus 5 volt DC. When the gates terminal heats up, accordingly the path of collector and emitter will get activated. Okay. Then accordingly, what you can observe, the voltage VCC, that will go to the ground, and finally it will become a 0 volt, right? Okay. Now basically, as we all know that the ground voltage, that will be 0 volt only, and to the optocoupler you can observe the NOT gate will be connected. NOT gate will be like this. Okay. So as we are getting the 0 volt output, and we are providing this 0 volt to the NOT gate, and accordingly, as we know that the working of NOT gate, when the input is 0 and our output will be 1, right? The output is nothing but, this output is nothing but input trigger PLC, right? So this is how optocoupler will work. We can set up to isolator also. We require this isolation on input side as well as on output side also. Now here you can see this figure. In this figure, what you are observing, the 24 volt the DC power supply is here. The few inputs are connected, and the one card is given here, right? PLC input card. Actually, this is the digital input cards having total 8 inputs, right? And here what I have mentioned some normally open contacts. We can see DNO also. Okay, the one for the push button, and the second one is for the temperature sensor. Okay, so as we have discussed in the PLC signal flow. For example, if I'm seeing the address, I'm writing here I colon 1.0/0, right? So here I is nothing but the file letter or input. We can see one means or the slot number. In the upcoming session, I will explain this part in detail. Actually, this address belongs to the SLC 500, means for the modular techniques. Okay, just forget it. Just focus on this concept. So here I'm just telling you the last part. Last part means what? In the software, what we can see bit, but in the hardware, what we can see, this is the terminal number, right? So as you can observe, this is the 0 number terminal. This one is the first number terminal, right? So to the first number terminal, we have connected the push button, open push button. We can see it the start push button also, start push button or the PBLs. And to the third number terminal, what we have connected, we have connected the temperature switch. Means as per our requirement, we need to connect the input terminals, right, or the input field devices also. So here the positive and the negative. So here we have provided the 24-volt DC power supply to this input. Actually, what we can see, this is the source type input connection. Source type input connection. So basically, for that purpose, at least you should have knowledge of the source and sink concept. In the upcoming session, I will try to cover this part so that you will get the knowledge of the connections regarding source and sink input and output connections as well. Okay, now the common is also required here. This common is all for these 8 inputs. Right? Now coming toward the output module. So the same thing we have to learn in case of the output module also. So there are 2 different types of output module. The first one is the digital output, and the second one is the analog output. So as we have already discussed what is digital and what is analog, here we are just going to understand the examples and when we require and how we can able to connect the output module to the PLC. Basically, the output module is a link between the CPU and the output devices, right? So here I'm just showing you the PLC signal flow. Here you can observe. So this one is the CPU, let us assume, and this one is the output devices, right? So basically, the output devices is linked between the CPU and the output module, right? This one is the most important part. So here you can observe the examples of digital output module. The solenoid valve, lamp, pump is there, footer, motor, right? So many digital output devices are available in the industrial sectors, right? So here you can see the required power supply: 24-volt DC power supply, 115-volt AC, and 230-volt AC as well. But in the earlier we have discussed about the required power supply to the PLC, that is the 24-volt DC. But here you can observe the output. You can observe that may be a 24-volt DC and the AC as well, right? For example, here I'm just showing you the figure. In this figure, you can observe the output card, right? Total 8 outputs are here. How many? 8 outputs are here, right? So among that, we are just using third terminal and the 7th number terminal. To the third terminal, we have connected one motor, and to the 7th number terminal, we have connected the 24-volt lamp. Actually, it is work on 24-volt DC power supply, right? So as we know that here, if we are providing the input to the CPU, it will execute the input, and accordingly we are getting the output, but the output will be of 5-volt DC, right? Which is coming from the CPU, that will be of 5-volt DC. So if you are using a lamp which is working on 24-volt DC power supply, so it is not possible to turn on that lamp by using 5-volt DC. So how is it possible? So it is possible only by using providing the external power supply, right? So here you can observe to the third terminal and to the 7th number terminal, which we have connected to the relay. Means if we are getting the output from CPU, we are using that 5-volt DC output to trigger the relay coil. Means we are just using that 5-volt DC output to switch on the output devices like a 24 DC lamp and the motor which is working on 110 volt AC power supply, right? Means the relay which we are using for the switching purpose, means switching on the devices and switching off the devices, right? Okay, so the relay is the very important part which you can observe in the PLCs. Basically, how the relay will work. When you are providing the power supply to the relay, the coil of relay will energize, right? And when you are removing the power supply, the coil of the relay will de-energize, right? So it's a very simple thing. You just need to remember the relay is just like an actuator. It will switch on and switch off the PLC output, right? Now here, in order to fulfill the AC power supply requirement of our motor, here we have connected the external power supply. Here you can observe like this. Okay, and if we are getting the output from the CPU, then accordingly the relay will switch on and it will start the motor, right? And when you are releasing the switch, here you can observe here we have added the push button also. When I press the push button, then accordingly the motor will start, and when I'm releasing the switch, then accordingly motor gets off, right? The same thing will happen in case of the seventh number output also. So when you are getting the something input, then accordingly the lamp which is working on the 24 DC power supply turn on, right? So all these are the very important points which we should know. The most important part about the output module here, the types of output module. The relay type output cards are available, the transistor type output card available, triac type, and the isolated common type, right? So as per our requirement, we have to select all these type of output card. Relay type card available with the AC as well as DC also, the transistor for the DC only, triac for the AC, and the isolated common type that will be for the different voltage devices. Okay. So if you are observing the relay type cards in the software, we have to recognize, we have to detect it by this RLY. Okay. And for the transistor type, you will get like this trans. Okay. You can observe the trans in your output card. The trans means what? The transistor type output card. And RLY means what? RLY means the relay type output card. Okay. Now before coming toward the next component, we need to understand the concept of sink and source, right? So that's all about this session. The rest of the part, the sink and source concept, we will learn in next session. Thank you.